Hello, my name is Darryl, President of Vacuum Pressing Systems. In this video, I'm going to talk about glue. Glue predominantly for veneering, which I am very passionate about. It's often the glue that determines the success or failure of a panel, which is why I take the glue I use quite seriously. With this in mind, I'd like to take a look at the 5 glues that most woodworkers are familiar with, as you can see here. The most used and popular woodworking glue is PVA, which stands for polyvinyl acetate, commonly called white or yellow glue. Hands down, this is the glue most woodworkers have in their shop. For some, this may be the only glue they use. Epoxy is another woodworking glue, which is excellent for exterior work, although used much less than a PVA glue, usually in specialty situations. A similar glue to epoxy is this polyurethane glue, used even less, but also a great exterior glue. And this is urea formaldehyde resin glue, which is an excellent veneering glue. We'll talk about this glue later. And lastly is contact cement, water-based and solvent-based, used for specialty applications like gluing plastic laminate countertops. You know, now that I think about it, there is a 6th veneering glue called hide glue made from animal parts that was used extensively for quite a long time before more modern user-friendly glues replaced them. It can be a rather challenging glue to work with, especially the flaked version with the glue pot that you see here. So I am not going to discuss it more than this mention. So the question is, of the 5 glues I talked about, how many of them are well suited for veneer? I think the answer lies in understanding the definition and properties of veneer itself. Let's come at it with this question. When is a piece of wood veneer? Can this 3/4 inch board be considered a piece of veneer? How about this board at 3/8 of an inch? What about this piece at 1/8 of an inch? Where's the line where a piece of wood would actually be considered veneer? My definition is this: when a piece of wood is cut thin enough, approximately about 3/32 or less, in this case a 1/16 piece of mahogany, and glued to a stable substrate like this piece of MDF, where all seasonal movement, its power to expand and contract, is overcome, then I consider this a piece of veneer. Now there are 3 factors that play a part in this: the piece of wood itself, the substrate, and the glue. Each one of these needs to meet a certain criteria to create a stable veneered panel. Since this video is about the glue part of the equation, let's have a closer look at what I recommend you consider in the glue. If the glue's main purpose is to hold the veneer from moving at all, no expansion, no contraction, then the glue's primary quality should be rigidity, as hard as possible. With this in mind, let's consider the 5 glues I talked about earlier. To demonstrate this point, I have poured out a strip of these 5 glues on a sheet of plastic earlier and let them fully cure. Let's examine the contact cement first. Look at this glue. If hardness and rigidity is the primary quality, this glue is a total fail. It's far more flexible than the veneer it would attempt to hold. Yes, contact cement allows you to glue veneer without a press, but the bond is simply too soft. I probably sell more vacuum presses due to contact cement failure trying to press veneer and then the veneer bubbling up than any other single reason. I would never consider this glue for veneering. Now let's look at the PVA glue. Definitely way harder than the contact cement, but still some flexibility. Here's the epoxy, harder still, quite hard actually. This polyurethane is a little hard to judge due to the foaming action as it cures. My sample would be pretty similar to the epoxy, if it didn't foam up like this. Let's look at the urea resin glue. Now that's hard. It won't even bend a little without snapping in half. Hands down, this is the most rock rigid of the 5 glues I've talked about. Nothing compares to the rigidity of urea resin glue, although epoxy and polyurethane are decently hard. What makes these 3 glues, the urea resin, the epoxy, and the polyurethane, the most rigid of the 5 glues I've talked about is that they bond and cure by chemical reaction. Because of this, these glues, unlike PVAs, do not soften with increased temperature or moisture. Let me do this simple demonstration to show you what I mean. This is a common household heating pad that I will put the epoxy, polyurethane, urea resin, as well as the PVA glue under. Turn it on and let it sit for 10 minutes or so. Okay, this has had time to warm up the glue samples. Look at this PVA glue. It's just about as soft and flexible as the contact cement was. Here's the epoxy, no difference. The polyurethane, same. And the urea resin, still rock rigid. So now let's look at this same test except with moisture. I have these 4 glues here soaking in this water for about an hour, so let's have a look at how they handle moisture. So this is the polyurethane. As you can see, no different there. Here's the epoxy. No different there. Here's the urea resin. Snap rigid, same as before. And here is the PVA, which has been dissolving and getting quite mushy in the water. As you can see, it's all over my hands. So this is what happens to PVA with some moisture. Before we move on, I want to talk about one more thing around moisture and PVA glues, and that's about the PVAs that are rated waterproof. So let's look at that same demonstration with just the PVA waterproof type glue. So here I have a waterproof PVA soaking in water, and it's not dissolving like a regular PVA, but it's still extremely soft. I can really sort of curl, look at how I can just curl that around. So it does soften it, very similar to what happens under heat. So just to be clear, a waterproof rated PVA glue still will soften, it just won't dissolve. Now I know that your veneered panel is not going to be floating in water, or at least I assume it won't, nor is it going to be subject to temperatures in the 100-some degree range. My point is these 3 glues are not affected by temperature and moisture at all, where PVA glues are. So even with humidity and change of temperature, a PVA glue is affected to a small amount, where chemical reaction glues are not. With this in mind, I'd like to talk a little bit more about the chemical reaction glues. Now, although epoxy and polyurethane are very good veneering glues, and they have no moisture in them, so there's no shrinkage, both bleed through the veneer excessively and are rather messy to work with. I prefer urea resin glues, first and foremost because of their high rigidity, but also because they bleed through much less and the mixed glue can be cleaned up with water up to a point. Not to mention it's significantly cheaper than epoxy or polyurethane. Now you might think, after all I've said about the superiority of chemical reaction glues, that I would never recommend a PVA glue. Just because I consider a urea resin the premium veneering glue does not mean I never use a PVA glue. Because sometimes I do. A PVA glue will hold most veneers just fine. It's more a matter of the subtle movement that this glue cannot completely overcome. Now you might say, why would I want to use a PVA glue when I know these other glues are superior? Well, I look at it that if I don't need their performance, a PVA glue requires no mixing. You can pour the extra back. It cleans up easily with water. And it's considerably cheaper. So let's look at my considerations for whether I use a PVA glue or I step up and use a urea resin. The question I ask is, under what circumstances would I use a PVA over a urea resin? I have a list of 6 conditions, whereas if I say yes to any one of them, I will use a urea resin or possibly epoxy or polyurethane. If I say no to all 6, then I will consider using a PVA. Here's my list. 1. Highly figured veneers, like burls, crotch veneers, and any others that have the grain going in different directions, as well as being delicate and fragile. This mahogany crotch veneer is highly unstable, and I want all the rigidity I can get to hold it in place and prevent fissuring up the middle here. 2. An oily veneer. This East Indian rosewood needs a urea resin, epoxy, or polyurethane that can handle its oily nature as well. A PVA glue may not hold this veneer well enough. 3. A panel with veneers going in multiple different directions. Although a PVA glue will hold these veneers in place, the opposing forces going in different directions will most likely show crack lines in the finish at these joints. 4. Horizontal surfaces. Again, the PVA glue will hold the veneer just fine, but faint movement at the veneer joints can show up and get noticed more on a horizontal surface like a tabletop than on a vertical one. 5. A high polish finish. Any subtle movement at the veneer joint can show up as a faint crack line in the finish for sure. You want as rigid of a glue as you can under a fancy finish. A PVA glue will not guarantee this. 6. Large panels. This situation does not necessarily relate to rigidity, but it does relate to the glue's open work time. PVA glues tack too fast to practically roll out an entire 4x8 panel and get it in the press fast enough. Urea resin glues, as well as epoxies and polyurethanes, have much longer open time to accommodate large panels. There is one more consideration to this picture, and that is whether or not it's a backed veneer. A veneer can come on a backing, usually paper backed, wood backed, or phenolic backed. When a veneer is glued to a backing, you're not really gluing the veneer, you're gluing the backing, which means the veneer is very stabilized and doesn't really apply to these rules, except on a really large panel where you still need the open work time. Otherwise, just use a PVA glue all the time. Now that I've given you an overview on when to use which glue, let's take a closer look at their qualities, both the PVA and the urea resin. The PVA first. Know that all PVAs are not created equal. With this type of glue, some set faster, some set slower. Some are thicker so they don't run when you glue vertically. Some are thinner so they spread well with a roller. Some cure out harder, some softer. When I'm considering a PVA glue for veneering, I look at 4 qualities. First and foremost, hands down, is hardness. As hard as possible. I want to get as close to a urea resin as can be achieved. Let's go back to the sample glue testing I did earlier. You'd be surprised at the range of hardness with PVA glues. Here is a very common PVA glue and what I would call the mid-range of hardness. Somewhat flexible, somewhat stiff. Here's a particularly soft one, surprisingly marketed for veneering. I would not use this glue on my veneer. Here's an extra hard one that I developed. Not as rigid as a urea resin, but still pretty darn hard. Here's one that has a waterproof rating. Note that it is still in the mid-range of hardness. The additive that makes this PVA waterproof does not make it any harder. Next would be open work time. Generally, when veneering a panel, you need extra time to spread the glue, especially on a large panel. All PVA glues have a relatively short open work time compared to urea resin, epoxy, and polyurethane glues. Some will start to tack in as little as a few minutes, and the most you'll get out of this type of glue is about 15 minutes, depending on temperature and humidity. Choose one that specifically mentions longer open work time. Third is spreadability. Because using glue for veneer means spreading it on a larger surface, usually with a roller, rather than a narrow edge, a thinner PVA will spread much easier than a thick one. Here's a thick one, and here's a thinner one. When I hold it vertically, the thick one stays put, whereas the thinner one starts to run immediately. The runny one is much better for spreading with a roller. Last, and far less common, is a bleed-through blocker. This is an additive specifically for minimizing bleed-through on commercially sliced veneer. Here are two ash samples. I tinted the glue black to show any bleed-through clearly. One with no bleed-through blocker and one with. See the difference? It's not a guarantee of no bleed-through, but it definitely minimizes it. Very few PVAs have this quality. If you can find it, it's quite useful, especially on open grain woods. Now, getting all four of these qualities in one glue was not something I could find. I could get a few of them, but not all four. So I went to work and developed one. It's called Unibond 1, and it comes in half gallons, gallons, and 5-gallon pails. It can also be used as a general all-purpose woodworking glue. Now let's take a look at urea resin glues. This type of glue is far more similar brand to brand than a PVA glue, except for one exception. You can get it in a powder that you mix with water, or a liquid that you mix with a powder. The powder you mix with water is cheaper than the liquid version and costs less to ship because it's much lighter. The main advantage of the liquid version is in keeping the catalyst separate from the resin, which prevents a low-level chemical reaction from taking place. Whereas the all-powdered version has both parts rubbing up against each other in the container. Even a small amount of humidity can cause a low-level chemical reaction, compromising the glue's bonding ability. Either version has a shorter shelf life than a PVA glue, with the liquid version showing up by thickening on itself. When it's fresh, it's the consistency of, let's say, maple syrup. When it thickens to the consistency of cold honey or molasses, the shelf life is up. With the powdered version, it can be very hard to tell, something I think is important to know. The other advantage of the liquid version is you can put more or less of the catalyst into the liquid to speed up or slow down the chemical reaction. This is not something you can do with the powdered version. The liquid version also mixes quite easily, where the powdered version tends to lump up and can be difficult to get a smooth, non-lumpy consistency. As you can tell, I'm a big fan of the liquid version. This doesn't mean that the powdered version doesn't perform well, because it does. I just like the control and the added features of the liquid version. Now, mainly the liquid version is used in big industry in hot presses and is not so available to the small user. So I went ahead and took a regular liquid urea, modified it so that it set faster and performed well at room temperature. I call it Unibond 800. It comes in half gallons, gallons, and 5-gallon pails with a choice of 3 different catalyst colors: a white, a medium brown, and a dark brown, as well as a white tint and a dark brown tint. There is also a bleed-through blocker additive specifically meant for Unibond 800 to minimize bleed-through when desired. One last thing to consider with urea resin glues, and that is the issue of temperature. Of all the glues I've talked about, this glue is most sensitive to having a minimum temperature that must be maintained, which is 70 degrees, no and if and buts about it, which can be a real challenge in cooler climates. I recommend a simple household electric blanket or a heating pad thrown on top of your vacuum bag with a blanket on top. This keeps your work well within the temperature range that this type of glue needs. In fact, the higher temperature, the faster the cure. Well, I hope this video has given you useful information about glues for veneering and will assist you in choosing the right glue for your next veneering project. As always, feel free to call us anytime if you have questions.